In this video, we are going to go over the final method for solving systems of linear equations, my personal favorite, the elimination method. So by now you have learned how to solve by graphing, finding where two lines intersect if they do, by using substitution, which is great for if you have a variable on its own, and now you're going to learn the elimination method. It is great for when you have two variables on the same side of the equation. In that case, the elimination method is awesome. Why do we call it the elimination method? You're going to see it in action right now, and it's going to make sense with that name. So here, the whole goal is to eliminate one of the two variables. So I look at these equations and I look at the like variables. I have x's and I have y's. With the x's, it'd be really sweet if I could eliminate them. And I can, if only I could add -6 and 6. And that's the important step. You are looking at the like variables and saying, what operation would I need to do to get rid of that variable? So if I could add these, then they would go to 0. Now you can't just add -6x and 6x. You must add the entire equations. The reason being is this equation is a line, and so is this. And if we add them together, we'll still get a true statement. It's not going to be the same line, but we'll maintain truth as long as we do the same operation to everything in the equation. But again, the important part is we've determined addition is the operation we're going to use because -6x plus 6x is 0. So now let's add the equations, and this is just so rad, and in my opinion, very magical. -6x plus 6x is 0. They have eliminated themselves, hence elimination. 2y plus y is 3y. 16 plus 20 is 36. And now from here, well, basically just recognize the rest of this is like what you did when you used the substitution method. You're just going to solve for y and then for x. And if you have no idea what I'm talking about, watch those substitution videos back. So a great way to get very good at elimination is actually just practicing this step here and eliminating correctly, and then going on to the next 5 or 10 problems and just getting to this step. Then you go back and practice what is going to be a review, which you'll see right now. So now we're going to solve for y, so we have 3y equals 36, and I divide both sides by 3, and that leaves me with y is equal to 12. Oh yeah! Now remember, what we're doing is finding where these two lines intersect. That would be at a point, an x and a y value, so we must solve for both variables here. I'm going to take y equals 12 and I can plug it into either equation, but I think the second equation is easier to plug into because there's nothing I need to multiply by. So I get 6x plus y, which is 12, is equal to 20. From here, I'm going to solve for x. So I subtract 12 from both sides, and I get 6x equals 8. And then I divide both sides by 6. So x is equal to 8 over 6, which if you divide the top and bottom, or numerator and denominator, you will get 4/3. So you're dividing that by the greatest common factor of 2. So that's our x value. So the point is 4/3, 12. And you might say, a fraction? How can that be? Well, let's use that point to check our answer in the equation that we have yet to plug into with numbers. So that would be this equation. So here's our check. I'm going to do -6 times 4/3 plus 2 times 12. I'm getting these numbers from x and y, plugging them into x and y, and we want to know, does it equal to 16? Well, 4/3 of 6, that would be 3 goes into 6 twice. That would be -2 times 4, which is -8. Plus 2 times 12 is 24, which is indeed 16. So if you're looking at this check saying, what's the deal with the fraction work? Go back to chapter 1 in Algebra 1 and review your fractions so you know how I'm checking it and why it's working. The point is, the point works. Nice. All right, we're going to do one more of these, but this time I'm going to show you that you can use subtraction. Now here, I've got the m values, but they don't have the same coefficient, the number next to the variable. However, these c values do. So if only I could subtract these values, then they would eliminate themselves. So that's what I'm going to do. I'm going to subtract the entire second equation from the first equation. Some teachers will, instead of subtracting the whole equation, teach you to distribute the negative to every term and essentially then add a negative. But adding a negative is subtracting. So I'll subtract everything here with our goal to eliminate the c's. 4m minus 8m is -4m. 2c minus 2c, that's 0. Negative 3 minus a negative 4 is, I believe that's going to be, well, what do you think it is? Negative 3 minus a negative 4, positive 1. Nice. So yeah, we're going to have some fractions to deal with here, but we can rock that. So I've got negative 4m equals 1. Divide both sides by negative 4, and you get m is equal to negative 1/4. And you might think fractions can't be the right answer. I thought, let me give you some problems with fractions in it to show you that it can be. So now I'm going to take this answer, like with substitution, like with the last problem, and plug it in for one of the two m values. I'm going to use the upper equation because you're multiplying by a smaller number. So I've got 4m, which is now negative 1/4. Sweet. And that's going to be plus 2c, right here, is equal to negative 3. And I'll solve away. What's 4 times 1/4? Well, a fourth of 4 is 1 with a negative, so it's going to be negative 1 plus 2c is equal to negative 3. I'll add 1 to both sides. Don't be scared by the fractions. That leaves you with 2c equals negative 2. I'll put this work over here. 2 goes into negative 2 because we're doing some division there. Negative 1 time. So those are our answers. M equals negative 1/4, C equals negative 1. Now we could check our answer by plugging into the equation we've yet to plug numbers into, which would be the second one. So if you're up for it, and I know you are, I take 8 and I multiply by negative 1/4, that's M. I add on to that 2 times C, which is negative 1. And the question is it equal to negative 4? Well, a fourth of 8 is 2. It's going to be negative 2 now. Minus 2, because negative 1 times 2 is negative 2. And negative 2 minus 2 is negative 4, which means we're right. Practice elimination step, folks. Eliminate those values, get it to 0, get one variable alone, and then notice that the ride is the same as what you've been doing since substitution. Peace.